people actually gone through that academy and gained different levels of qualification. So we've tried to address that as well. Simon, I know I mentioned earlier on the community investment program. That's been very key. Each of our contractors is required to have a community investment plan. They are required to identify what those local needs are, so it's not just a generic approach to this that they might actually do on any project. It's about them understanding the specific needs of that local community and tailoring their plan to that. As Crossrail, we've invested heavily. Our time and focus has been on the Young Crossrail programme, working with local schools and promoting very much around STEM subjects. Another key area, and one that's very dear to my heart actually, is around responsible procurement and particularly ethical sourcing. So I want to touch on this. It's a bit of the forgotten part, I think, of the sustainability story. We're very good at identifying the immediate impacts around our site, the impacts either within our site or just outside our site boundaries. But when they talk about things like ethical sourcing, this is very, very distant from us. It's several tiers down the supply chain. Very easy to forget that there are issues around there. And this has obviously been highlighted more recently by the Modern Slavery Act, but we put some requirements in the contract very early on. There was a recognition that we need to address this. So we required that all contractors had to comply with the Ethical Trading Initiative wherever possible. Now, we were either sort of brave or stupid to do that. It has been a challenge, there's no doubt about it, but it has started to ask that question of our supply chain, so that there's a real focus on where those materials come from. And as I say, it is a slow burn, it's a slow journey, but we're slowly starting to get the message out there, further down the tiers, that we are actually very serious about this, and that if these players want to continue to work on public sector funded projects in the UK, then they need to be able to demonstrate that they're actually addressing these issues. So just another point on this slide. This is actually the definition of responsible procurement as defined by the Greater London Authority, the GLA. So it's defined in these various areas, and all of these areas are picked up somewhere in our contract information. So our contractors need to be able to respond to these and demonstrate through a series of plans how they're meeting these requirements. Just want to touch on very quickly on innovation. And Maggie, who will be talking to you after lunch, will talk a lot more about the context of this. But just a few things in terms of the area that I deal with in terms of the sort of environmental sustainability options. And some of the challenges that we have. And again, this idea of trying to think a little bit differently about the way that we do things, get away from the sort of business as usual model. Now, one of the biggest impacts that we have is on rebuilding a huge piece of infrastructure, a lot of metal, a lot of concrete being used on this project. Now, I don't know how many of you remember your O-level chemistry, certainly A-level chemistry, if not O-level chemistry, but to make concrete you need cement. Cement is a conversion of calcium carbonate to calcium oxide. The equation has to balance, so you're releasing large amounts of CO2 into the environment. Not only that, you're using fundamentally sort of fossil-derived fuels in your kilns as well, so they're emitting lots of CO2 as well. So there's a bit of a double whammy there for in terms of cement manufacture. Anything you can do to reduce the cement content, the cement replacement in your concrete is going to fundamentally reduce your carbon impact in your embodied carbon. So we've been looking at how we can do this. These are different concrete mixers, and we can actually get that concrete embodied carbon down quite significantly. In fact, we've been working with a company, the David Ball Group, to look at cement-free concrete. So this uses 95% cement replacement. It uses a waste product called ground granulated blast furnace slag, which comes from the steelmaking industry, with an activator, which is a patented activator. So you can do away with this completely. Now, is this new technology? No, it's not. This is Roman concrete, basically. We've kind of come full circle. Before the advent of ordinary Portland cement, about 150, 200 years ago, something like that, this is basically the sort of technology that people were using. But we've lost confidence in this product. There are buildings 2,000 years old which are still standing, but we haven't got a modern standard that allows us to use this sort of technology now. So One of the challenges, again, to the industry is, how do we deal with this? There's a publicly available standard, PAS, which is in development at the moment, which will help to support the use of this technology in the future. And a PAS is a fast-track way of trying to actually get to a British standard. So in a few years' time, we may be able to use this sort of concrete more extensively. Another piece of work we did with a company called Newstone on lightweight aggregate. Now this lightweight aggregate here is made from the clay that we've excavated from our Crossrail tunnels. We get something like 7 million cubic metres of clay coming out from London. A lot of it went to Wadsey Island, which is a project with the RSPB to create a wetland bird habitat, which will probably be of European-wide importance, so a very valuable project in its own right. But we're also looking at the possibility of using the material for higher value end uses. So we were able to pelletise the material, put it in the kiln, and the clay bloats, creating this lightweight aggregate. We can substitute the granite in the concrete with the lightweight aggregate, and this is a 50-50 substitution. So we have less impact through using less natural materials, the granite from quarries, wherever the quarry materials might come from. So we're reducing that. We get a lighter weight concrete, 25% lighter. So again, that might have benefits. If you're a developer looking to build a high-rise building, if you're using concrete that's lighter, that might allow you to put another couple of floors on that structure with the same pile depth, for example. So that could have a significant amount of value to you as a developer. So again, some very interesting potential applications of this material. I think this is the last slide, the final slide here. Tunnel energy segments. Again, the tunnels can generate a lot of heat. There's a lot of reject heat, either from the braking energy and also from the fact that we've got reject heat from the air conditioning systems on the trains. So if the ventilation system switched off, the tunnels can go up to 40 degrees plus. So a lot of heat in that. And this heat typically radiates out, it makes the train warmer, it makes the tunnels warmer, and over a period of years the ground around the tunnel gets warmer. If you look at the section around the central line between Tottenham Court Road and Bond Street, for example, ground temperatures are typically 17 or 18 degrees centigrade, compared with the typical ground temperature in the London area of 11 to 12 degrees centigrade. This is over 150 years of ground heating from the underground system. So anything we can do to get heat out of the system is very beneficial. We can reduce the ventilation, we can reduce the cooling needs, and we can provide a valuable heating resource for any buildings that are above ground. So we looked at incorporating pipe work within our tunnel segments. You can see these little red lines. That's pipe work that goes through the segments. We can flow water through that to actually take out the heat and then distribute that heat. And this is a model that we built, which is using kind of perspex replacement segments, and you could actually see how this was embedded in the segment. So ground source heating technology, basically, but just being incorporated into our tunnels. Unfortunately, because of a timing issue, and again, a key lesson learned here is to be able to identify these things right at the onset, at concept design, and get them really embedded in the design. Very difficult to come along later on in the program when the design has started, people have actually identified their risks, their program and so on, and say, look, we want to make a change and we want to do something like this. So a very valuable technology, very useful but important to actually look at getting it in early enough. And we're hoping that projects like Crossrail 2 was mentioned, we've got High Speed 2 and there's some tunnel sections in High Speed 2 as well, that they may be able to look at this early enough in their program to look at implementing it. And hopefully, all of this will result in some sustainable outcomes. Just a couple of examples here of work. Paddington Integrated Project, which is actually finished, although not strictly as part of Crossrail. Crossrail actually managed the design, and the construction of Paddington, and this basically enabled us, by moving a number of activities over to that side of Paddington, to build the Paddington station for Crossrail itself, and integrate some of the other train lines at Paddington. An opportunity again to improve the urban realm there along the Regent's Canal that runs just along here, as well as green roof on the station. This is at Whitechapel, another very difficult area for us in terms of integrating this into the existing station at Whitechapel. And that Yeah, that's the end of my presentation.
Thank you. Thank you very much. So if you have any questions, I'm advertising for Michelle for a few moments. Questions, I might have.
Hi, just a quick question. I was just wondering, in terms of energy efficiency, is Crossway using any renewable energy, or is it incorporating that into the project?
Yeah, we are, but I must say, I mean, it's a very small amount. The major use of the energy is in the traction power. And way before my time on the project, there had been, I believe, a little bit of discussion about how we might supply that traction power, and whether it would be, whether there would be a dedicated power station, for example. London Underground used to own its own power stations in the past, fossil fuel ones. But what could argue that you could actually build and run a renewable powered power station or something like that. That was discounted and put in actually in probably the too difficult to do box at the time. So we've not really been able to do anything with the traction power. Central area stations, again, we're very limited because they're underground stations and we don't own any of the space above it because they are given over to oversight development. So again, to have anything like PV technology, again, we're very limited in what we can do. And also the actual amount of energy that we'd be providing with that would be quite token as well. So again, the opportunities are limited. We do have one or two areas where we have been able to do that. Whitechapel, that last station that I showed you, does have some roof that we can use, and we've got a fairly substantial PV array there. We also have some large depot structures which provide us with a huge roof area, and they have photovoltaic and some solar thermal panels on them, as well as ground source heat as well. We're using thermal piles, so we're getting the benefit of the heat from the thermal piles. And thermal piles, we do have thermal piles at the stations as well, at Bond Street, Tottenham Court Road, Farringdon and Liverpool Street. We have thermal piles. Now we don't actually need the heating, but one thing we want to do is get rid of the heat, but we had a one-off opportunity to really future-proof those sites so that oversight development could make use of that heating and the cools that might derive from it. And the other thing that we've concentrated on really is the energy efficiency. So we try to do it with energy efficiency because our opportunities for renewables are a bit more limited.
That's excellent. It's clearly a world-class project. Brilliant.
Thank you.
Let me just ask something about, like the ticket barriers and stuff like that.
Yes.
They must open and close thousands of times a day.
Yeah.
And I've never known it myself to be a fluid process to walk through them, frankly. Now, in other countries though, like I spent time in Japan, their ticket barriers are always open and they only close when you don't swipe. How much have we looked at best practices in other countries or recruited external expertise in to give us like an independent audit for perhaps best practice and ways to improve what we've already got? Is that clear?
Yeah, no, it's a very good question, and in fact, I think the process in truth has probably worked slightly differently. We've gone and visited others, and spoken to them rather than kind of invited them over and sort of had a comprehensive session with them, I would say. So there has been a process, maybe kind of slightly differently. We also, effectively Crossrail are acting as a developer for an asset that we're handing over to somebody else. So again, some of those decisions haven't been exactly ours. We need to fit in with the current mode of operation of the London Underground system, and that's the barrier system that they have gone with. That's a fair question because one should be challenging of that, and I think there is a need to look at how that works. Again, just in terms of passenger throughput, it can in peak hours it can actually be a bit of a problem. So I think that's something that we need to consider. Again, coming back to the renewable energy subject as well, in some of the Japanese stations they have looked at piezoelectric plates in front of the passenger gates as well, so that they can generate a little bit of electricity to operate the gates and so on. So yeah, there are things that can still be done. But I would say that there's nothing to prevent us benefiting from the next generation of that, actually when some of the efficiency issues, cost issues and so on have been dealt with. So we haven't precluded that possibility in the future.
is Bechtel's role in terms of the overall project?
Bechtel are what we call a project delivery partner. And so Crossrail as an organisation is made up of a number of different organisations. There's a programme delivery partner and a project delivery partner. That was back in about 2009. So it is about managing that whole design and construction process, the programme, the costs, and so on. And, you know, obviously, well, I say obviously, but subsequently there's been a bit of a change, and we work now as a much more integrated organisation. It was changed to an integrated organisation in 2011, something like that, 2011. So we're very much embedded, and, you know, I don't think anybody, until I put Bechtel in that slide, Simon probably didn't know I was Bechtel, I don't know, he might have. So we're very much as an integrated organisation, and various individuals are embedded in you know, numerous different roles within the project. I think we've got about 160 Bechtel people on the project at the moment.
Thank you very much.
Okay, thanks.
So I think it's time to close this session. Thank you very much, Matt, for a very comprehensive